Okay, last little bit here, example 4b. Again, I'm going to do two parts, so you can see both of my examples here that we're going to go through. I have ax to the 15th, all to the negative 2/3. And then just like the second part of that example for A, when I see a quantity to a negative exponent, I like to get rid of the negative right away and make this 1 over everything. Ax to the 15th to the positive 2/3, because then at least I have that negative exponent out of the way. Now from here, when I have that whole quantity to an exponent, that exponent goes to everything. So I get 8 to the 2/3 power, and then x to the 15th to the 2/3, the power to a power, I multiply these exponents. And 2/3 of 15 is 10. Now again, I'm actually almost done here. I have to take this 8 to the 2/3 power on the bottom, which means, it's a different color here, the cube root of 8 squared. Now I could do the cube root of 8 first and then square it, or I could do the cube root of 8 squared underneath. And both ways work. I can find a solution. I can simplify both ways. It's a little bit easier, I think, to do the cube root of 8 first, because I know the cube root of 8 is 2. 2 squared is 4. X to the 10th. Okay. Now, as far as the absolute value goes, I have 3 as my denominator of my rational exponent. So I have a cube root, which means I don't need absolute value here. Final answer is 1 over 4x to the 10th. Okay, example 4b. 9x, 4 through to y, to the 2/3 power. All right, I have this radical, I have this rational exponent. Let's at least get consistent. So just like in example 4a, part A, I'm going to start off by changing this 4th root of y to a rational exponent, y to the 1/4 power. And then this is all to the 2/3. Okay. Now everything goes to the 2/3 power. Take 9 to the 2/3. And then x to the 2/3. And then y to the 1/4 to the 2/3. So I multiply these exponents and I get 2 over 12. Which that 2 over 12 simplifies to 1 over 6. So I'm going to go ahead and make that change here too. Everything else is the same, but this is y to the 1 over 6. This looks really messy. Lots of rational exponents. But let's start here. This 9 to the 2/3 power is the cube root of 9. Oh shoot, there's not a cube root of 9 though. Okay, so let's write this as cube root of 9 squared, like this. Which is the cube root of 81. Well, shoot, that's not going to work out either. Okay. I can simplify that, though. So I guess I might as well go ahead and do that. Because 81 is 27 times 3. And the cube root of 27 is 3. So this all ends up being 3 cube root of 3. Okay. So I'm going to just kind of leave this for now and come back to it in a second. Now over here, though, I still have x to the 2/3 and y to the 1/6. Well, shoot. I want these to have the same root. So how am I going to make that happen? Well, I can't really make this 1/6 to be anything to the something over 3 power. Really, I need to make this x to the 2/3, x to the 4/6 power. And then I have y to the 1/6. Now that's at least good because then I have the 6th root in both places. Okay, so if I combine these two pieces, I get the 6th root of x to the 4th y. Okay, so I have the 6th root of x to the 4th y here, but then I have this cube root over here. Well, shoot. So I'm going to look back. I have this 3 pulled out in front of everything. I'm going to look at this cube root of 3 part here. If I change this back to a rational exponent, this is 3 to the 1/3 power, which we could make 3 to the 2/6, and that's okay too. And then that at least gives me the 6th root. So that's the 6th root of 3 squared, which is 9. Okay, so after all this work, I have all these pieces that I just need to put together now. I have the 3 up front. I have my 6th root in all of the places now of 9 x to the 4th y as my final answer. And I can't simplify anything else. I don't need absolute value because I don't have any variables in front. This one was a really tough example. There's a lot of things I had to do. We started off on the right track and then, oh shoot, we have a cube root here, 6th root here, even more work to do. But we get there in the long run.